Years, you're going to have to take a course in differential equations at some time, and this is the first time you're going to see like a baby differential equation. Okay, it's like it's the easiest one. So in many natural phenomena, a quantity grows or decays at a rate that's proportional to their size, as in populations that are bigger tend to grow faster, populations that are smaller, right? Does that idea make sense? Okay, suppose that you have a function and y equals f of t, this is the population size, and as long as you have an unlimited environment, so adequate nutrition and immunity to disease, you assume that the rate of growth is proportional to the population. And what this means is that the rate of growth is the derivative. Does that make sense? This is what the derivative is. And if it's proportional to the population, that means it's equal to a constant times the population. And the population is just y. So that is that dy dt is ky. And that's an example of a differential equation. Another way to say this is that the derivative of y equals constant times y itself. What the constant will be depends on the situation, but there is a relationship to where that constant has to go in the function, which we'll talk about in just a second.
That'll be whatever you're working on. The constant will come from whatever problem you're working on.
Yeah, the constant will depend on how quickly your population is actually growing, especially the rate of growth of the population, like in percent per year, annual growth rate. Okay, and here is the theorem. The only solution to this differential equation is this function, which is often written as, we'll say, C0 e to the kt as well. So I like that notation better. Okay, so first of all, let's talk about what it means to be a solution. What it means to be a solution. So if you're a solution to an equation, it means that when you plug that thing into the equation, it works. Does that make sense? Okay, so in this case, checking to see if this y function works in that equation involves looking at its derivative. Does that make sense? Okay, so what is, if I have a function y is c sub 0 e to the kt, what is the derivative of that? It's c0 e to the kt times what from the chain rule? Times derivative kt, which is k. And you see how this thing is really just y. So that's dy dt is y times k. Well, y times k is the same thing as k times y, right? But that last k, this k came from the chain rule. Okay, so two things before we move on. Why did I put a sub 0 on that c sub naught? Or why did they say y of 0? That is always your initial population size. So like if you take this equation, y equals c0 e to the kt, and plug in t equals 0, you get y equals c naught e to the k times 0. That's e to the 0, which is just 1. So that's your initial population always. And k is going to be your rate of growth. Have any of you in a pre-calculus class worked with like the functions that describe interest accruing with money? Okay, and then do you remember what the equation was for continuously compounding interest? P equals P0 e to the RT. Does that make sense? Where P0 was your initial investment and R was the interest rate that you were given. It's the exact same thing, except for I have different letters, right? They use R instead of K, but effectively it's the same idea, okay? So, I mean, money is it's just the thing that's growing is your money, as opposed to like bunny rabbits. So, you know. Okay. So this is actually gonna have a lot of pre-calculus in it, not a whole ton of calculus. So we have this population being the number of flies at time t, where t is measured in days. If there are 100 flies for the second day and 300 after the fourth, find a model for this population growth, and then figure out when the population will be 10,000. So do we know the initial population size?
No.
No, we don't, which kind of sucks because that would be the easy number to fill in. But you know that you have 100 flies after the second day. That's the point 2, 100. Like time is 2, population's 100, which is the same thing as 100 equals c e to the 2k. What other point do you have?
4, 300.
4, 300, and what would that be?
300 equals CE to the 410.
Is everyone okay with how those two equations at least came from the words?
4K is my favorite resolution.
Okay, now from that, you've got to somehow find C and find K, and what you use is you use substitution. So what is the easiest thing to get by itself in one of those equations? C or K? Probably C, and I would just do the first one. So this is the same thing as 100 over e to the 2k equals C, right? And then you can take this thing and plug it in for that C. So 300 equals 100 over e to the 2k times e to the 4k. What happens to those e to the k things? Tries to e to the 2k because you're doing division and the exponents subtract, right? So that's 300 equals 100 e to the 2k. Divide by 100, yep. So 3 equals e to the 2k. Then ln both sides. ln 3 equals 2k, right? And k is equal to 1/2 ln 3. Is everyone okay with that? Okay, so that's part of it. Now, can you find your C? Back to that. C is 100 e to the 2 times 1/2 ln 3. I think it's 100 over 3. Do you guys agree with that? I mean, there are lots, and that doesn't make a whole ton of sense because that's a partial fly, as in not a whole number of flies. But that could be because you maybe made some errors in estimating how many flies there were, or it could be the case that maybe I made this problem up and that made it not work out nicely. And so both are possibilities. But do you understand why this became a 3? The 2 times the 1/2 made a 1, right? And then the e and the ln could cancel, giving you just 3. So your population equation is 100 over 3 e to the 1/2 ln 3 times t. And if you're working with these things and stuff like WebAssign, don't round unless you're asked to. Because if you round here, you can introduce errors that make your answer off by quite a lot, actually. And why can't this e and ln cancel? What's in the way? That 1/2. If you're clever, you can make them cancel, so I can show you how, just in case you're interested. So that's the same thing as e to the ln of 3. What's the power on it? 1/2? And now that's all to the t. So I think that becomes 3 to the 1/2, still to the t power. You buy that? So that's 100 over 3 times 3 to the t over 2. And so you could also do that. That's because this part cancels out to 3 to the 1/2, and this is still a power there.
Why would it be times
Why would it be times
t?
t?
Why wouldn't it be, why is it raised to the t power and not times t?
Because you simplify this part, and that simplifies to a whole number. But the fact that, and you kind of think about that in parentheses, the fact that this was raised to a t is just still outside of it. And it wouldn't be exponential growth anymore, it would be linear growth otherwise. So. Okay. We were asked another question, weren't we? What were we asked? When will it be 10,000? Okay. So take an equation and put in what for y? Put y as 10,000. Let's just, which one, do you want to use this one or do you want to use this one? Want to use the last one? Okay, sure.
Isn't it simpler?
It is a little bit simpler. So 10,000 equals 100 over 3, and it was 3 to the t over 2, right? Yeah, okay. So multiply the 3 over, and you'd have 30,000 equals 100 times 3 to the t over 2. Divide by 100, and how many of those zeros go away?
If you multiply it by 3, wouldn't the 3 to the t over 2 also be multiplied by 3?
Mm-mm. No, because you multiply each side by 3, and that 3 gets used up canceling this 3. It's not distribution, because there's no addition.
It's all one term.
Oh, I was thinking the addition, sorry.
Exactly, this is totally fine. Okay, divide by 100, and we get what, 300? Do you agree? Pretty sure 300. 3 to the t over 2, because you cancel out 2 zeros, I think.
Yeah.
Most days I can count, but not always. It's good to ask. Okay, now how do you deal with the t in the power? Natural log. It's natural log's purpose in life to take powers down. It takes them out. Okay, sorry. Jokes on a Monday, sorry. T over 2 times ln 3. Right? And then can I do the last step I'll do in one, multiply by 2, and divide by ln 3. So 2 ln of 300 over ln 3 equals t. And I got that that's approximately 10.384. What was our time measured in days? Does not take, so don't give your fruit flies a compost pile inside of your house.
So that we would have.
How fast they die?
I don't know. This actually accounts for it.
Oh, does it?
Yeah, the rate of growth accounts for it. It does do births minus deaths kind of a thing. So that's what that, I mean, if taking that initial, unless you had no death like early on. What was your, sorry?
So you'd have to use a calculator for that, right?
Oh, yeah. I don't know, WebAssign asks you if it wants stuff as decimals. It will say round your answer to the nearest blah. And if it doesn't say round, it wants the exact answer. So that's how you know. But the other thing is that if you round too soon, you can get it wrong. You can just, which is called round off error. And I just didn't think about it ahead of time to bring it in, but there are examples where if you apply this to the whole money situation and you round too soon, in your computations you can be off by like thousands of dollars in how much money you have, and in this case thousands of fruit flies. So don't round until the end. Okay. No, I can't. So, can imagine 10,000 mosquitoes though. So a bacteria culture initially contains 10 cells and grows at, English, a rate proportional to its size. After an hour, the population has increased to 400. Find an expression for the number of bacteria after T hours. So the fact that it grows proportional to its size means you can assume you have this kind of rate of growth. That's what that means. It means you have a thing of the form c naught e to the kt. Just like when I say it's linear, you can assume it's y equals mx plus b. And this one's a bit easier because you know what the initial population is. What is it? 10. So where can 10 go? In for y or in for c0. So that can be 10 e to the kt. You could put it in for y, 10 equals c0 e to the k times 0, and that's going to give you 10 equals c0. Okay, that's also fine. If you didn't remember, that's where the 10 went. Okay, after an hour, the population has increased to 400. So that's the ordered pair 1, 400. So you put in 400 for y and 1 for t. Whew, so what, 40 equals e to the k, right? And k equals what? Okay, so your expression is y equals 10 e to the ln 40 times t. And just because you can, that's the same thing as 10 times 40 to the t power. Because e to the ln of 40 is just 40. I'm pretty sure WebAssembly will take either one of those answers, as long as with this first one, you make it pretty obvious that your ln 40 and your t are both inside the exponent, which you can do by just using the little exponent button, right? Okay. So what does part B say then? Okay. So let's use the 10 times 4t to the t. It's going to be huge, right? 10 times 4t to the third.
Difficult to track all those zeros on a calculator.
Well, it's not that bad. 40 times 40 times 40. What's the 4, the 4, and the 4? And how many zeros? And then one more zero from the 10, right? Does that make sense? So it'd be 640,000. Get out your Lysol.
Probably not very many.
Hmm?
Said in the grand scheme, probably not very many.
Perhaps. I don't know. It depends on what kind of bacteria we're talking about too, right? So, I mean, if it's something sort of benign, if it's the bacteria inside of your yogurt, then not such a big deal. But if it's like E. coli, then maybe we're upset. We didn't specify which one it was.
Especially if you've got almost 750,000 after 3 hours.
Exactly.
I wonder up to which temperatures can E. coli survive?
I have no idea.
So if
Yes.
it wasn't proportional and there was some type of like catalyst to it, would it be different?
Yeah, so if you add some, if you decide to, say, introduce Lysol to the equation, or introduce giving them sort of like additional nutrients, or there's a limiting population size, it's much more complicated. We're not going to do anything like that. Like this doesn't even account for the fact that certain times you have a carrying capacity. Does that make sense? And it doesn't account for that at all. There's a different equation that accounts for the fact that there could be a carrying capacity. Do you guys know what I mean by that? Like the population goes up, but then levels off, right? Or if you're bunny rabbits, it goes up, levels off, crashes, goes up, levels off, crashes, right? And the links follow it, exactly, yeah. And also I think that before the bunny rabbits, or also the willows follow the rabbits as well because they kill them by eating, that's why the population dies. Okay. This is the one place there's calculus. Find the rate of growth after 3 hours. That means how fast is the population changing, right? So your equation for the population size was, I think it was 10 times 40 to the t, right?
Yeah.
So the rate of growth is the what? Derivative. So dy dt would equal 10 times, what's the derivative of 40 to the t?
40 to the t times natural log of 40.
Great job. 40 to the t times natural log of 40. and then plug in 3. So dy dt will equal 10 times 4t to the third times ln of 4t, which without a calculator, you could say it was ln 40 times whatever that is, which is 640,000. But it's about 2,360,882. Well, 883 approximately. What would the units of that be? Mm-hmm. So the population is exploding, right? That's what exponential growth is. It's kind of like the the human population. Starts low, you get the dark ages, then penicillin's invented, and all of a sudden, boom, right? So we stop dying at young ages. Okay, would the rate of growth be faster at 3 or at 1? When is the population growing more quickly?
3.
Later on, right? Because you can think about this is what the curve looks like, steeper slopes out there versus down there, right? That's what exponential growth property is. It stays kind of level and then all of a sudden, kaboom. Okay. When will the population reach 1,000? So this is just pre-calculus, right? Your population equation was 10 times 4t to the t. How would you find when that reaches 1,000? Exactly. So 1,000 equals 10, 4t to the t. Divide by 10 and you get 100 equals 4t to the t. Now what? Ln 100 equals ln of 4t to the t. And ln's purpose in life is to pull that power down. And t is ln of 100 over ln of 40. Which I just got was 1.248. What was this measured in? Hours. So after 1.248 hours.
I thought it was log-based 40 of 100. Actually, that's the same thing.
It is the same thing. Yep. Log base 40 of 100 is that's how you would evaluate that. It's the change of base formula. Yep. It is equivalent. You got that. Okay. Not very bad, right? No. Okay. When we did one of the really, really early units, I taught you a way to just get the equation for this half-life thing by kind of thinking about it. I also want to show you how to do it with E's and LNs. Okay? So if you just think about it, so you have this radioactive element, I think it's called cesium? Cesium. Okay, so you tell I haven't had chemistry for a long time. So the half-life of cesium is 30 years, and the explosion at Chernobyl in '86 sent about 1,000 kilograms of that into the atmosphere. So find them, and its half-life, so find the mass that remains after 30 years. Okay, so in the whole, just we think about it thing, we took the initial population size, which was that 1,000, right? Times 1/2, and what was the power on that 1/2? Do you remember? You multiply by 1/2 when you plug in 30. So this has to be t over 30. You can kind of convince yourself by plugging in the various things that's correct. After 30 years, you have 1,000 times 1/2. After 60 years, you've got 1,000 times 1/2, okay? Now, that comes from having like lots of practice come up with those equations. If you forget that, you can also do this. You can use E's, okay? So first of all, what goes in for that C naught? 1,000. Okay. You know the half-life is 30 years. How could you use that info to get another point? When t is equal to 30, then you plug in 500. You could also use 60 and 250, okay? But you see what I'm saying? After 30 years, you have half of your original. So 500 equals 1,000 e to the 30k, or k times 30, same thing, right? You buy that? Okay, what next? Divide by 1,000, and that's gonna be 1/2, right? Equals e to the 30k. Then what? ln of 1/2 equals 30k, great. And then k will equal, or 1/30th ln of 1/2, same thing, right? So then your equation is 1,000 e to the 1/30 ln of 1/2, all that times t. Okay, so that would have, this equation, as long as you put your exponent in parentheses, will accomplish the exact same thing. It's also equivalent to that one. So to show you why, here's the first thing you can do. Make that 1,000 e to the ln of 1/2 to the power of 1/30th, and all that's to the t, like this. Pull the power of 1/30th up, right? And then the e and the ln can cancel, right? Giving you 1,000 1/2 to the power of 1/30, and that's still to the power of t. And then those exponents multiply and give you back what you had in the beginning. You don't, if you were, say, doing this for WebAssign, you can just leave it like, or your homework, you can just leave it like that. It's not wrong. It's just that it's just a little bit more ugly. Do you agree?
And finding one of those exponents is rough.
It's a pain in the butt, right? Yeah, so if you understand how these exponents can simplify, the only slightly tricky thing is that this t will always end up being in the exponent. So other than that, it's just ln properties, and you can't cancel e and ln until you've moved the powers up. That's the other thing, right? So that's it. Okay. So if even 100 kilograms remains in the atmosphere, the area is considered unsafe. So when is Chernobyl going to be safe? So take that equation we have, 1,000 e to the, nope, not, let's do the other one, 1/2 to the t over 30. And what are we going to plug in? 100 for y. And when that happens, from that point on, you're going to be okay. This probably greatly simplifies the chemistry because these things probably disperse and are not equal, and I think the radioactive stuff is very different from one place to another, even they're kind of close together. I think that I've heard this. I just know the math. Okay, first step is to divide by, and we get, I think, 1/10. Do you buy that? So 1/10 equals 1/2 to the power of t over 30. And then natural log both sides. Pull your power down. Oops, I made a boo-boo there. Yep, should be ln of 1/10 on the left side. Okay. And your t will equal 30 times ln of 1/10 over ln of 1/2. My calculator told me that was approximately 99.658 years. So effectively 100. So in about 2086-ish, right? I don't know if I'll make it that long. I'd have to be 102. I guess I can't go to Chernobyl.
Well, but it says at that point that it's still unsafe.
Yeah, but from that point on, it will be safe, right? Because that's when it is 100 exactly, and so, you know, you go like,
Wait a day.
wait a day, and then it's below, right?
99.9, you can go in there.
Yeah, I mean, like, and safe is relative, right?
Yes, what is
It also,
considered?
safe might also be an overshot as well, right?
And safe means you won't glow when you come back.
Safe means you won't glow when you come back.
Tourism now.
You enjoy your trip, you're positively glowing.
There's areas
Well,
right there where you
here's
can
the
go.
thing about.
Yeah, there's areas where you can go. It's like
Long
eco,
before
there's some
you're glowing.
eco-tourism.
You absolutely can't go or can't stay for more than a couple minutes, but.
Yeah. Anyway.
River Monsters guy went fishing in the cooling lake at Chernobyl.
Oh, jeez.
Remember, if
He
you
was
jump into a vat
contacted
of
by
blue,
catfish that were living in the cooling lake.
That show gives me nightmares.
Let's not watch that show.
will either
Just to
die
do
or come out with super.
Research on monsters is great.
All right, one last thing. Shh. One last thing, and then it'll be done with this lesson. So a sample of radioactive. Okay, I can't say this one either. Is that tritium?
Yeah, let's try it.
Okay, great. Decayed to 95% of its original amount after a year. What is the half-life of tritium-3? So it must be kind of short if after a year it's almost gone. Does that make sense? Now, the kind of crazy thing is you don't have to know the initial amount to figure out this half-life. Yes?
I think when it says decayed to 95%, I think there's 95% left.
That's a good question. I should know the answer to
It
that.
says decayed by
Decayed to
95%.
95% of its original amount.
Yeah, okay, it means 95, so it's got a long half-life then.
So it decays
Yep.
5% after.
It's lost 5%. Yes. Okay. So we have this equation, y equals c0 e to the kt. Yep, you're right, and I even did it that way.
So it's 5% loss.
So it's 5% loss. Yes. Yep, but my bad. Just misinterpreted that. Okay. So does it make sense that when t is equal to 1, y is equal to 0.95 times c0? That's how you find 95% of a number, right?
Yeah.
Okay, so plug that in. 0.95 c0 equals c0 e to the k times 1. And it feels like you should have to know that c naught to know that initial population, but do you have to?
It's 1.
It cancels out, right? So you get 0.95 equals e to the k. Does that make sense? Okay. And then k is equal to
ln 0.95.
ln 0.95. So you have y equals c0 e to the ln 0.95 times t. Oh. How did I not see that? That's a great, easy pattern. Isn't that the same thing as c0 0.95 to the t? I think that's because it was after a year, okay? Like, had that been 2 years, it would have been a little bit different.
Because the t was 1.
Because the t was 1, yeah. The t was, yes, exactly, which meant that there was no sort of like other number in there, no.
So if t is 1, you can just jump right to there.
If t was 1, you could jump right to there, but that might have just been me making a simple problem. Yes,
If it was 2, it would be t over 2.
it would be t over 2. Yep, exactly.
0.95 t over 2.
It would be, if there is definitely that pattern. It's kind of like the half-life pattern. Yep. Okay, so there's your equation for the amount of tritium after any amount of years. Now, you want to figure out what the half-life is. So this is the population at t equals whatever, and by population, you know, I mean population of radioactive thing, right? It would be an animal, it'd be population. How would you figure out what the half-life is? What is the initial amount? Almost. You plug in 1/2 C0 for y. Because C sub 0 is your initial amount, right? You want to figure out when is that half of the initial amount. So that'd be 1/2 C0 equals C0 0.95 to the t.
That cancel out.
And the C0s cancel out again, yep. You have to leave them there because it would be, otherwise you wouldn't have an equation that told you, how much of whatever you're looking for. But 1/2 equals 0.95 to the t. Natural log both sides. Pull the power down. And t is ln of 0.5 over ln of 0.95. I got, that was about 13.5. So that was a kind of a two-step thing. First, to figure out what the half-life was, you had to figure out what the equation for population growth was, and then from there you could determine the half-life. Would part B be any different, really? How long would it take to decay to 10%? How, just put in 1/10 instead of 1/2, right? Exactly. How about you try this? Put in 1/10 C0. So you start with your equation, y equals C0 0.95 to the t. 10%, you plug in y equals 1/10 C0, or 0.1 C0, and then solve for t. It's the exact same thing.
Just ln +1 over.
Exactly. Oops.
Which have no idea what that is.
Oh, yeah. No. I also realized one thing. Wolfram alpha is one of those places that's bad for certain stuff. I am pretty sure if you use Wolfram alpha to find like derivatives and things,
It's not.
well, there's not that, but I think like if you say take y equals a to the x and find y, I think it says log, doesn't it? And that's been, if you read their little fine print, they say log really means what?
ln.
Really means ln. So just FYI, that does happen sometimes. It's an aside, but
I noticed that.
you notice that? Yeah. So if you're using them to check your answers, it's completely legitimate. I mean, use your resources, but
Is that because of this is their program?
I don't know why. Some ln is definitely common in tons of stuff, but like I said, my statistics software used log for ln, and I had to specify if I wanted base 10. So it's just not. It's mostly ln, but you have to be careful. Like use the language that you're given. So I think ln is the more common name, but some software, for some